Okay, so as was previously mentioned, remember that this unit is going to be extremely factoring heavy. Make sure you recap going over doing factoring by GCF, dots, grouping, trinomials, tricky trinomials. All of those things are going to be very much a part of this unit. We're going to be talking today about simplifying rational expressions. And when you hear rational expression, I just want you to think a fraction. Instead of a fraction just being a number over number, though, it's going to be an expression over an expression. The way we are going to simplify these fractional expressions or rational expressions is to take the numerator and denominator and factor them completely. That's going to definitely be key. Once we see common factors in the top and the bottom, we'll be able to reduce those common factors to be a factor of 1. So for example, if you think of the number like 5 over 5, I think most people can see that that would come out to be 1. You can kind of think of that like canceling the 5 from the top and bottom. And again, remember, as you cancel out, it never comes out to be 0. You're canceling to a factor of 1. Now the same thing is going to happen, only now it's going to happen with an expression. So maybe it would be something like x plus 5 over x plus 5. The fact that that's the exact same expression in the top and bottom, that will reduce, just like 5 over 5, to be a factor of 1. Now it's important that you're careful as you do your cancellation. Again, if you see something like x plus a over x plus a, same exact thing in the top and bottom, those are canceling out to be a factor of 1. Remember that addition is commutative, so if I switch the order of things, this is technically the same thing as x plus a over x plus a. So that actually still cancels to be a factor of 1. I'm going to skip ahead to the last one. Remember that subtraction is not commutative. So if I were to try to rearrange the order of the a and the x, I can't get the exact same expression that I have here. When you reduce two terms that are the exact same two terms, but with a subtraction sign in the middle, and they are in the reverse order as you see here, these are going to cancel out to be a value of -1. If you want to see an example, let's say we said that x was like 5 and a maybe was 3. If I were to actually subtract them, maybe I do 5 minus 3 over 3 minus 5. You'll see that this would reduce to be 2 over -2 or -1. Pick any other number for the x and the a, and you'll see the exact same thing happen. So again, this is a special case. Two terms, reverse order with a subtraction sign in the middle. Those can cancel out to be a -1. Please, 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 I will say this a million times as we go through this unit. If you have something like a binomial over a single term, the binomial is locked together. This plus in the middle, think of that like chains that lock the x and the a together. So the only way to get rid of an x plus a would be to have an x plus a somewhere in the bottom, and you can't just add that in if that wasn't there. Okay, so please do not do any sort of cancellation when there's pluses or minuses. These terms are fully locked together. A cancellation, as you see in the bottom, is illegal. Okay, so as we go through these examples, as I said before, the most important thing you can do first is to factor completely. Okay, so as you do your factoring, remember your steps. You're going to first be looking for a GCF. If there's 2 terms, then you can try dots. If there's 3 terms, you try some sort of trinomial factoring. And if there's 4 terms, then you use grouping, which probably won't happen as frequently. So as I take a look at the top of this one, I see 2 terms. There's no GCF. They're both perfect squares with a subtraction in the middle. So that's how I know that this is going to be a dots problem. This will factor to be x plus 5, x minus 5. In the denominator, I still see 2 terms, but remember again to first look for a GCF. I can take an x out of both of these terms, and as I do, I'll be left with an x minus 5. So that's actually factored now. As I look in the top and the bottom, I see an x minus 5 and an x minus 5. Okay, so those whole expressions are exactly the same. That's why I'm able to cancel out these expressions to be a factor of 1. Now, you don't really have to write the 1 there. I'm just putting that there for emphasis. Eventually, you would do something like x plus 5 times 1, and the 1 becomes irrelevant. So you could just put x plus 5 all over x. Those are the only things left. once again, I really want to highlight you cannot cancel these x's together. The only way to cancel anything here would be to have a whole x plus 5 somewhere else in the bottom of this expression. So this is actually your final answer in this case. The goal for all of these problems, by the way, is to create equivalent expressions. So if you take a look at a question like number 3. Yeah, so in number 3, I will again start by factoring completely. As I look at the top, I'll take a 6 out of those terms. I'll do GCF. I'll be left with an x plus 3. The factoring the bottom is a little more complicated, so as I do this one, I'm going to use tricky trinomial factoring. So as I do that, I will put the 2x squared plus 5x minus 3 just somewhere else on the paper so I have a little more space to factor it. Remember, with tricky trinomial, you're going to start by multiplying the first and last terms together. That becomes your m. Your a term is your middle term. You're looking for two numbers that multiply to be a negative 6 and add up to be a positive 5. Be careful with that 5-6 combination. In this case, it's actually a positive 6x and a negative 1x. You'll take down your 2x squared. You'll bring down your negative 3. And remember, once you've split your middle term, then you do factor by grouping. So I'm going to chop it down the middle. I'm going to GCF the first half. As I GCF the second half, I'll take out a negative 1. Remember, the signature thing of factoring by grouping is that you get the same parentheses in each half. Now I'll factor out that common parentheses and put everything that's left over in its own parentheses. I personally like to put these in a little thought bubble, so that way they're kind of like out of the way. And now I'm going to replace my whole denominator with the final expression I had here, x plus 3 times 2x minus 1. So again, I look and I see now that I have an x plus 3 in the top and the bottom. They're identical, so I'm able to cancel them out. Technically, again, they're canceling out to a factor of 1. I'll take the 6 that's left over in the top and the 2x minus 1 that's left in the bottom. There's no way of reducing that any further. Again, the 2x and the negative 1 are locked together like chains, and so that is actually my final answer. I'm going to go down to question number 5 now. In question number 5, again, I'm looking at the top. I see a GCF. Be careful because this time I see a number first, but I can still do regular GCF here. I'll take a 6 out and I'll be left with 4 minus x. In the denominator, I see a trinomial. That trinomial begins with a regular x squared, so it's not a tricky trinomial, so I can do regular AM method for this one. That means I can split it up to two parentheses with x and x. Two numbers that multiply to be 12 and add up to negative 7 would be a negative 4 and a negative 3. So as I look at this example, I see I don't have the same exact parentheses, but these two parentheses are pretty close. They're the exact same two terms, but they're in the opposite order with a subtraction in the middle. That is our special case. This is the kind that could cancel out to be a negative 1. You can put the negative 1 in the top or you put the negative 1 in the bottom. It's totally up to you. What's important is that you'll have to multiply the negative 1 by whatever else is here. So this would be a negative 6 now in the top and an x minus 3 in the bottom. And that would now be your final answer. Again, technically the negative could go in the bottom, but you'd have to put a negative 1 in front of the parentheses, x minus 3. So take a look at question number 6. Again, I'm going to start by factoring completely. You should never cancel until you're fully factored. In the bottom, I see two terms, so maybe I'm thinking dots, but then when I look closely, I see there's a GCF. And as I take out my GCF, I have two parentheses that are exactly the same, one in the top, one in the bottom. So I'll cancel them out to a factor of 1. The only problem is I can't just have this 3x in the bottom magically become a numerator. If everything cancels out and all that's left is denominators, you'll have to put a 1 in top as a placeholder to make sure your denominator stays a denominator. So 1 over 3x would be your solution in this case. Okay, so I just have one more example I'm going to go through, and I'm going to ask you guys to finish up the remaining examples with any class time and then for homework. I know that 11 will be a little bit of a challenge question, but at the same time, it pretty much fits in with all of this. Factor completely and cancel common factors from the top and the bottom. So as I look at question number 7, the key thing here is I need to make sure I factor completely. Both of those look a little more complicated, so I'm going to do each of them off on the side in like a little thought bubble. And again, as you start to factor, you're first looking for a GCF. So I'll pull an x out of all these terms, and I'll be left with an x squared minus x minus 42. Again, you need to make sure you're factored completely. I see a trinomial left in this parentheses. The fact that that's a trinomial that begins with x squared, I know that's a regular AM trinomial. So I can break that up into two parentheses, both starting with x. The two numbers that multiply to 42 and add up to be -1 would be 7 and 6. That will be a -7. The bigger number always matches the sign of the middle term, and since they're multiplying to a negative, they're opposite. Major important thing, don't forget to bring down that GCF. Okay, I need to replace my whole numerator here with the expression x times x minus 7 times x plus 6. In the denominator, that 2 I'm going to pull to the side so that way I have a little more space to factor it completely. Again, you don't have to do this. I don't personally like to rewrite my expressions over and over again. I like to do side work. I see this time I have a GCF of 2 that comes out of all these terms. And thankfully, as I GCF, I get a regular AM trinomial left in parentheses. Okay, not a tricky trinomial. So as I break that down into two parentheses that both start with x, the two numbers that multiply to 21 and add up to be 10 would be 7 and 3. -7, because again, bigger number always matches the middle sign, and this time they're the same since they're multiplying to a positive. And again, important thing, don't forget to put that GCF back in front. You'll replace the denominator with your entire expression. I see some common factors here, an x plus 7 and an x plus 7. Those can cancel out to a factor of 1. By the way, it's only a 1-for-1 thing. If there was another x plus minus 7 somewhere, I can't just magically cancel that 1. 1-for-1 because they're making a factor of 1. When you do your final answer, you don't need to remultiply everything. You just need to put them back next to each other as like factors being multiplied. You don't need to actually distribute the x or anything like that. Okay, so the remaining questions left of these 11 questions are your classwork, and what you don't finish up will be homework, and then we will go back over this tomorrow as we get started on multiplication. Thank you.